With number 11, we have a product of 5x and the square root of the quantity x squared plus 1. Now x squared plus 1 under the square root is the same thing as x squared plus 1 to the 1/2. So we can eliminate that square root. Obviously we can see it's going to come back, but it also means that we've got a chain rule here inside of a product rule again. Okay, so we have to find dy dx when x is equal to 3. So let's get dy dx. Alright, so as we mentioned, this is a product rule. The derivative of the first term will be 5, and we're going to multiply that by the second term. So that's the quantity x squared plus 1 to the 1/2. Derive the first, keep the second. Plus, now keep the first, so we keep our 5x. And we're going to multiply that by the derivative of the second part, which is where the chain rule comes into play. Alright, so we have an inner function to the 1/2 power. So the 1/2 is going to come out front. The new exponent will be negative 1/2. Alright, so we derive the outer with respect to the inner, and then we multiply that by the derivative of the inside, and the derivative of the inner function is a nice quick 2x. So we need to evaluate this when x is 3. Now we can plug this in right away, but this is a non-calculator question on the exam, so we need to really kind of put this more together back in terms of square roots. All right, so we've got 5 and then square root of x squared plus 1. And then over here, well, we've got ourselves a fraction. All right, so we see that we got 1/2. All right, 5x is in the numerator. 2x is in the numerator. And then this is to the negative 1/2, so we know that that's going to come down into the denominator. So it'll be down here, but it'll be to the positive 1/2. I'm going to put it way down here. But we don't want the 1/2 exponent because we don't see it, so we're going to go back to square root x squared plus 1. So there's dy dx. Now we got to punch in 3. So we have 5, and then we have the square root of 9 plus 1. Plus, and then our fraction, we plug in 3, we get 5 times 3, or 15, and then 2 times 3, which is 6, and then we have twice the square root of 9 plus 1. Alright, so 5 square root of 10, and then we have 6 times 15 is 90, 90 divided by 2 is 45, so 45 in the numerator and square root 10 in the denominator. And that is D. For number 12, we're up to the second derivative now, d2y dx2. We are almost given dy dx. In order to get dy dx all by itself, we'll need to move the x plus 2y over to the other side. And this is dy dx, but now we want d2y dx2. So we're going to take the derivative with respect to x of both sides. And I got to do it over here as well. And as usual, this requires the quotient rule. All right, so on the left side, we have d2y dx2. And on the right side, we're doing a quotient rule. So, bottom, d top, derivative of 2x is 2, minus derivative of y is dy dx. Minus, I didn't make my fraction bar long enough. Now we keep the numerator, 2x minus y, multiply that by the derivative of the denominator, x derives to 1, and 2y derives to 2 dy dx. And this is all over the denominator squared. Here's d2y dx2. We want to evaluate it when x is 3 and y is 0. All right, so in doing so, all right, what do we have? We have 3 plus 0, and then we have 2 minus dy dx. Okay, so what's going on with dy dx? Well, here's dy dx. Well, let me write it over here again. Dy dx was 2x minus y over x plus 2y. Now we need to evaluate it at the point when x is 3 and y is 0. So what ends up happening? We get 6 minus 0 over 3 plus 0, or 6/3, or 2. So we're going to replace dy dx with 2. Right? And that's actually good. We like seeing zeros. It helps us simplify. Minus. All right, let's keep going. 2 times x, so 2 times 3, minus y, which is 0. And then we have 1 plus 2 times dy dx, which we already figured out was 2. And that's all over, again, x is 3, y is 0, and that's being squared. Okay, so 3 times 0 minus 6, that's 6 right there, twice 2 is 4, plus 1 is 5, all over 3 squared. So it looks like we have 0 minus 30 over 9, which simplifies to negative 10/3. That was a good amount of work there. I'm sorry, I'm off the screen a bit. Okay, let's hope the next one's a little bit easier. We got an inverse for 13. Okay, we know our rule for the inverse. All right, we know that g prime of x is equal to 1 over f prime of g of x. All right, that's our rule for the inverse. That's what you want to have ready to go for the quiz. So, we're asked to find g prime of 1. G prime of 1, therefore, is 1 over f prime of g of 1. We're told that f of 0 is 1, but since g is the inverse of f, that means g of 1 is equal to 0. So this g of 1 right here is now going to be 0. So we have to plug 0 into the derivative of f. So let's get f prime. We see that f of x is 2x plus 1 all cubed, so that derivative will require a chain rule. Derive the outer with respect to the inner times the derivative of the inner. Now we want f prime of 0, so that means we're going to have 3 times 0 plus 1 squared times 2. So obviously that's going to be 6. So f prime of 0 is 6. So 1 over f prime of 0 is 1/6. And the answer is